Professor Maurício Bergman. Basically, he is graduated in mining engineer from the University of São Paulo. He also did his master's and doctorate at the same university, and I was a part of his evaluation committee for the master degree. Throughout all these phases, he was an engineer at Vale for 7 years, and he worked in Sossego and Bico projects, which means a great field experience. In the last 2 years, a few months ago actually, he had another experience. He was a visiting professor at the University of British Columbia. He is studying, working with the industry, and has one foot in Brazil and one foot outside. Following the tradition of the University of São Paulo, Professor Maurício works in different areas, two of which are very close, which is the pre-concentration area and the comminution area. So you will be able to see some ideas and about phosphate comminution. Good morning, everyone. It's a great pleasure to be here with you today. I thank Professor Luiz Marcelo for his presentation, and Helenice, André, thank you for the invitation to be here with you today. For me, it's very special to be here. As I said to my friends, it's we're coming back to presential events, right? Because after the pandemic, we didn't have presential events. And as Marcelo mentioned, I went to Canada. I spent 2 years in Canada carrying out research in comminution. And it's a great pleasure to be back here, seeing my colleagues that I hadn't seen in so long. I have talked to some. I still haven't had the time to talk to others, but I hope to catch up with everyone in the next 2 days. It's a great pleasure to be here. And as Toninho mentioned previously, I hope this event has a long life. This is organized by UFCAT. I also had an opportunity of being a professor in these new universities that were created in the process of expanding the higher education at the University Federal of Alfenas. We see people from Mato Grosso, from Araxá, and so it's very good to see the expansion of higher education and so many people developing so many interesting projects in academia contributing for the development of our sector. It's undoubtedly a wonderful time for me. I received the invitation from Professor André and Helenice, and I thought, what could I present here today? In the Federal University of São Paulo, we have work in the area of phosphates. This week, we published a paper showing how different minerals behave in the classification of a circuit from mosaic due to the difference in densities and so on. And then I thought, well, I know that there we will see a lot of things that the phosphate industry does. So maybe it's interesting for people to see what the phosphate industry does not do. So I will present you today. We are going to talk about the agitated charge mill, which is a different definition that's different from the ball mills that the phosphate industry is used to. So my idea is to show how this equipment can help the phosphate industry to decrease their energy consumption, which is such an important topic nowadays. So this is our agenda. To start with, we know that comminution is a phase that consumes a lot of energy. So if you look at data in the literature for industrial operation, the consumption of energy in grinding is around 30 to 50% of the total energy spent in a mining operation. In addition, minerals are more complex every day. The grade is going down, the particle size is smaller, there are several contaminants. We can say, for example, here we have seen a lot of people talking about the reuse of waste, which is an extra grinding phase as well. So, when I was developing my doctorate, I did a survey for the copper industry, and we can see clearly that from the first mine in Caracuã that had flotation, the first copper mine, and it was operated by the family of a famous Brazilian playboy. There are many interesting stories. This mine of Camacuã, they would grind at 212 micrometers. In the mine of Caraíba, reached 100 micrometers, and they created the regrinding process, so now they are with 40 micrometers. And then we had Vale. Vale got to the product of 40 micrometers, and Salobo, where we reached 20 micrometers. They are not grinding that low, but they had that as a project. And we also have hydrometallurgic projects that are not in the table. We have also Vale Verde, which started operation in Alagoas a few years ago. They also can reach 20 micrometers. So we can see clearly that there is a trend for increasingly finer grinding. And when we start doing this finer grinding, a tube or ball mill, it starts not to be as efficient. So around 100 micrometers, the ball mill is a traditional equipment that we have always used, but it's beginning to be replaced. It still has a lot of, it's very present in many industries. But when we talk about regrinding or fine grinding, really, the ball mill consumes a lot of energy during the grinding. That's where we have the agitated charge mill, which is different than the ball mill, where the cylinder moves the balls. In this agitated charge, you look from the outside, the equipment is still, and then you have a propeller to move the charge and transmit the energy to the ore and the balls. For these more finer applications, this equipment is much more efficient. It's 30% more efficient. This will vary depending on the application of the ore and the particle size, but still. So let me illustrate a little bit this agitated charge mill. It has a fixed external structure, and within you have this propeller that will move the charge and the ore. In the literature, we have a lot of descriptions of this equipment. In Brazil, I will show our installed base of this equipment. In Brazil, we see this equipment in the picture that we call the vertical mill or vert mill. These are the commercial names. It's a mill in the vertical position, but it can also be horizontally placed like the one we have here. This is ISA mill. It's a horizontal equipment with an axis and discs. The other picture here is the Minas Rio iron ore facility that has the greatest number of vertical mills in Brazil. We will see more information about that circuit later on. Within these different configurations and technologies, we have several manufacturers in the world. We have to highlight that this is a very consolidated technology. Metso is the leader in this sector. It has around 500 units that have been traded, or from a low up to 3 megawatts, which is a power that's very significant. And we have also Metso in a partnership with STM. They create the Hague Mill or VRM. It has different names depending on the brand, but it's the same manufacturer that makes both equipment. It's interesting to highlight that it also has an installed base, a very large installed base, 87 for the STM and I'm not 100% sure of the data after 2013, okay? So they have installed base that is very large. And it's interesting the power. They talk about 12 megawatts. So here you see, you start to see that it's for large installations, large facilities. We have other competitors of the Vertimill, Acitiki, FL Smith, Airich. Airich is a very traditional manufacturer of the Vertimill. The equipment derives from the first manufacturer that was Kubot, a Japanese company, and unfortunately with them I was not able to see what is the installed base, but I believe that it would be around 100 or 200 equipment in the whole world. I'm not sure, but it should be around there. In Brazil, what about Brazil? In Brazil, we have several plants that operate with this equipment. The first of them was Sossego, where I had the pleasure to work in 2004 in the startup, the ramp up of the plant. And we also have Maracá and Paraíba and Samarco. This is interesting. It should be highlighted. They have the vert mill and the ball mill, which is a case study that allows us to do this comparison from energy consumption. It's a work that has been awarded in the international conference of our area in Minas Rio, that is the largest operation in Brazil with 16 mills. Serrote da Laje, that belongs to Vale Verdes, that are the rig mills that do this very fine grinding, and Aripuram Anexa, and they have a new plant with 3 mills in their circuit of zinc, lead and copper. So you see, it's a technology that has been consolidated all over the world. It's a technology very widely used in Brazil, 10 operations basically in but it's a technology that has not really reached the phosphate industry. Let's see if we have room for that. So let's check and see what is the scenario of phosphate grinding in Brazil. Brazil is a very important both producer and consumer of phosphate, and we have diversified production with different kinds of companies, different sized companies. I didn't put all of them here, but we have here Semoc, Oroquém, Itafós, Mosaic, Ouro Verde. And what do we have in terms of grinding in Brazil? These are the lists of the operations. I do not cite the name of each operation, but you who are from the area probably will identify which operation is which. You have here phosphate, phosphate, phosphate. Why do we have several phosphate? Because sometimes we have some that process waste or tailings. So basically in all of the operations we have bar mills or ball mills. These are operations with relatively low capacity and the power up to 2000 kilowatts, and granulometer for feeding in primary grinding reached 20 millimeters. That at first it was done in the bar mills, but in the new plants or in the expansions of these plants, even the primary grinding is done with ball mill. And the granulometry or particle size of the product is around 200 to 500 micrometers. And in the second grinding, we have products up to 25, such as an application that we have for waste here. Now, for the phosphates itself, we have the application of 50 micrometers, 78 micrometers. So, except these primary applications where feeding is around 20 millimeters or 20,000 micrometers, we clearly have a large group of industries and mills that can operate with these agitated media mills, which receive a feeding of up to 1 millimeter. This has been studied, maybe 6 millimeters or 1 millimeters, at least with 1 millimeters everyone agree. So if we look at the current operations, we have 24 megawatts of installed power for these mills, which could be agitated media mill. Well, Maurício, what are you saying? We have to change our mills to replace them? No, that's not it. I'm just saying that there is a potential for expanding in new projects using this kind of technology with a significant saving in terms of energy, around 30%. Some operations, as you will see, operation 4, it's here twice because we had old data from literature and new data. So I thought that it would be better to put these two so that we could see the expansion and also how much finer the grinding is. In operation 4, this is very clear. We had a 78 micrometer product and now we have a 50 micrometer product. So for those who work with grinding, they know that this is a huge difference. So now, conclusions. The technology has been consolidated in the iron ore industry and non-iron ore industry, and we have a trend for increasingly bigger equipment in the order of 10 megawatts. We have a great variety of suppliers and manufacturers so that the companies are not hostage to one supplier. It's a promising technology, but it has not yet been used in the phosphate industry, and it presents a significant potential for reducing operational costs. I would like to thank CBFOS and all the companies in the area that provided the data for me to present, and also I would like to thank CNPq and FAPESP and the University of São Paulo for supporting our research and my participation here. Thank you very much.
Thank you, Maurício, very much. Thank you for discussing the state of the art when it comes to grinding. We have some time for Q&A, for a Q&A session. Okay, please raise your hands if you want to ask a question, and the microphone is going to be taken to you. Good morning. Congratulations for the wonderful work. My name is Marcílio. I am the mineral coordinator at CEMOC. We have a grinding study, and I would like to know how about the production of sludge, of fine particles in the vertical mill. Is there any comparative study regarding the traditional grinding and that one? Thank you, Marcílio, for your question. Outstanding question. We know that this is a very important aspect, okay? The generation of fine particles. The interesting thing about these pieces of equipment is that we can modulate the speed very easily when it's going up and down the equipment, and you have the pumping, the feeder. You can modulate this very quickly, and of course you need to work with the classification of your particles, okay, to avoid anything. So each case is a unique case, but this equipment can be operated very easily, and you can work so that you can calibrate it to not generate so many ultra-fine particles. Any other questions? Due to the time, I believe we can thank Maurício, Professor Maurício, and maybe chat with him during the next coffee break, okay, regarding these opportunities. Thank you very much, Mr.
Bom, tem uma plaquinha aqui de agradecimento do pessoal da organização, então